Okay, so I'm going to talk about a web serial terminal for ESP32forth. Um, so uh, the background, well, first of all, you might be wondering what is WebSerial. Well, it's a newish API. I think it came out in something like 2021 that allows a website with appropriate use of JavaScript to read and write serial devices or USB serial devices or even Bluetooth serial devices. It is, I believe, a proposed web standard, but it is something that currently the only available implementation exists in Chrome, but it exists for many of the versions of Chrome, so even on Chromebooks and Windows and Linux and so forth. But it is not, for example, supported currently in Firefox or some of the others. And what it provides is some methods to pair with one of these devices and methods for doing asynchronous I/O with those serial ports. I know this one's been in the works for a while because I used to work with some of the folks involved, and for a long time I think one of the worries was sort of how do you get the security properties right? You don't want some random website that you go to just be able to reach out and talk to your serial port. And so I gather there was a long discussion and eventually they landed on something. The API shape involves, it's nestled away under the navigator object. So there's navigator.serial, and then you can do request port, which will pop up a dialog that will ask the user to pair with a device. JavaScript of late has started using this idea called a promise, which is basically a result for something that will happen in the background where you can later sort of wait for that to happen and then respond depending on if there's an error or, and I'm sort of describing that poorly, but basically it's sort of a promise for something that will happen in the future. Oops. There's also an API called getPorts that will let you get the list of all of the devices that have been paired. And this is the way that you can, after having offered the user the chance to select a set of devices, you can figure out which devices are currently connected. There are also some events that you can register for that will let you monitor as devices connect and disconnect. And then once you've got one of these ports, you can then explicitly open it, and rather baroquely, you can then fish out a reader or a writer. A lot of these contemporary frameworks involve a lot of objects, and then with a reader or a writer, you can then do an asynchronous read or write using another concept that's been added to JavaScript, which is an array buffer. An array buffer is just an array of raw bytes. So what I thought was, well, I've got a bunch of different implementations of ESP32forth that all talk to the desktop computer via serial, and I happen to have a web version of µEforth, which is the forth that I run on these devices. And so, wouldn't it be nice if I could get the one talking to the other? And so that's what I set out to do. For the web version of µEforth, I actually have a notion of a what I call a raw string, and then the ability to evaluate a chunk of JavaScript, because ultimately the µEforth for the web is implemented as JavaScript underneath. So what I do to support serial is set up a buffer to store inbound data from the serial port. I make a simplifying assumption, which is that I'm going to deal with only one serial port at a time. So the support that I've added is not general. It does not let you talk to several at once. I figured that was unnecessary complexity for my purposes. I do keep track of the set of available ports, but I use the convention that whichever port is sort of the 0th port that's connected. That's the one that I'll focus on. And then I keep track of whatever the current writer is. If you just create and destroy the writers, they have this odd quirk. I think the intention is to make sure that there's a lot of edge cases, I think, in a lot of these modern APIs. They really want to make sure that every error condition is sort of trappable and catchable. And one of them is, imagine that you've got a device and you've been writing to it, and then suddenly the serial port or the USB port is disconnected, and maybe not all of the bytes made it through. They very much want to make it possible for you to know, did all of the bytes get through? Typically, I don't care, so I just want to keep reusing the same writer. There's a bit of a complex piece of JavaScript. JavaScript now has this idea of what's called an asynchronous function. It's basically a function that will, it sort of cascades like poison. If you've got a function that could be running involving some asynchronous operations, you are then free within that function to use an operation called await that lets you pause and wait for something to happen. Typically, JavaScript was designed originally to respond to events that happen in the browser, and so it's sort of never supposed to sort of sit and block anywhere. But with an async function, you're allowed to block, and so you can block waiting to open the port. You can then fish out the writer for that port, and then what I do in this particular loop is I then check to see if that port is readable, and if it is, I wait for for a character to come through from that. I release the lock that is on that reader because again, this is this property where there's sort of an explicit release of the readers, because you want to know not only, I've tried to read a serial character, but did I get all of the characters that were streaming from the device before the instant, say when it was pulled out of the slot. And then I push it into that buffer that I mentioned before. Push is in JavaScript is an operation for an array that sticks something at the back of the array. And so this little pump allows me to have a serial writer available whenever there's a device that's connected that I can write to, and a buffer that will gradually get filled. And then one more bit of sort of JavaScript magic that I have to do. I have an operation to monitor for updating of any of the changes to the serial port. So anytime something changes, I scan the set of ports, look at the set of ports, pick out the 0th port to be the port that I'm going to focus on. I blank out the writer because I don't want to use a writer for whatever the prior port was, and then I call that route serial operation in order to start routing data from that serial port. So a little bit tricky to figure all of this out. Sort of looking at examples out there. Not the easiest to use API, but I understand sort of why they're sort of trying to set it up this way. Not quite the way I would have designed the API, but it is what it is. And then there's a little bit of plumbing to this bit of code works around the fact that I run my JavaScript implementation both on a web page, but also I try to make it possible to run inside of headless tests that I can run. So this is sort of only operating when it's not headless. And then I listen for connection events, disconnect events, and then update the set of serial devices. So the net result is that you've got a buffer that contains whatever inbound characters and a writer that you could write to. And then you'll notice all of this gets JS evaled, and so then that's run in JavaScript. And then I have in my web µEforth a way of defining a fourth word that is implemented with a block of JavaScript. And there's two words that I use to plug things in. Two, I'm saying two, but it should be three. Well, we'll see when we get to that slide. So one is this pair serial operation, and all this does is it calls that request port operation, and then waits and it updates the set of serial ports. So this is giving the user the opportunity to pair with a device, and it'll unhelpfully send an error message to the JavaScript console if that fails for some reason. And then I've got this rather long name because this word gets stuck into references to it, get put into a deferred word and used elsewhere. But basically a word to read one character from the serial port, which a lot of work to get to that, but basically it looks and checks to see is there any data in this buffer. If there is, it returns 1 byte from the serial port. Otherwise, it returns a -1. So it's not a blocking word. It's just checking to see is there a character from the serial port, or else it returns a -1. Then there is a word to write a buffer, so serial type, that will send some number of characters to the port. If the port is available, it will quietly swallow it. If for whatever reason you're in a state where there isn't a port available. And this slicing magic is just a way to get to the data buffer that contains the forth heap inside of JavaScript. And so then finally we're in forth code after those two. And so I have this word serial that is just a big loop that creates a serial terminal. And so it does this by pausing, yielding to let other stuff happen in the task system in µEforth. And then I loop through and check to see while there is a key that comes in that is not less than 0, and then I emit that key, and then otherwise I drop the -1, and then I check to see if there is a key from the user keyboard. So remember, you're reading from the serial port and writing to the terminal, versus reading from the keyboard and in this case I'm able to use key question to check if there is a key available. If there is, I read it. I do this kind of awkward maneuver of pushing it onto the return stack, and then using the address of something on the return stack as a buffer. That probably says I should have had serial type print a single character if I was only using it for this application, but my goal was to sort of offer efficiently writing one whole buffer. And then that key gets routed to the keyboard, and then I repeat, and then the whole thing loops around again. So the net effect here is that we're redirecting any key that comes in, so we're repeatedly checking, is there a key from the serial port? Emit it. Is there a key from the keyboard? Send it to the serial port. So you're just redirecting the one to the other. I can then, µEforth can be embedded in a web page. So this is a tiny little web page minus the HTML sort of boilerplate at the top. And I can use a script tag to pull in µEforth. And then I can have my forth script tag. I define a word yes, no that reads in a key and checks to see if it is the Y character, and returns a non-zero value in that case, or 0 otherwise. All of those serial words that I mentioned are squirreled away inside of the web, confusingly the web vocabulary, because the web vocabulary has all of the platform-specific words. So I activate the web vocabulary. I define a word called go that prints out that you are in a serial terminal, offers to pair with a device, because the first time you see a device, you need to pair. And so if the user hits yes, then you can pair. If they hit no or any other character, it will continue on. And then it just runs that perpetual pump to route to things. This is actually junk. Oh, sorry, no, this is right. Sorry. So I switch back to the forth vocabulary just so that the system is in a well-known state, and then I call go, and so this will offer a terminal. So at this point, I'm going to transition over into a demo, and let me change the way I'm sharing. Actually, let me, actually, no, I can share from in here. So first, let me go to, so if you go to eforth.appspot.com, you'll get all of the Esp32forth stuff. But if you go over to this web tab, we have my micro eForth on the web. And, you know, as folks, let's do that. And, you know, it is a fourth and all of those things, and you can do C and C words and so on. Let me just give an example where I call some of these words directly. So if I go over into the web vocabulary, inside of this vocabulary is a bunch of stuff, but in particular, there's that serial word, and then also paraserial is in here. So I've got a device, and I don't know if folks can see in the small little window of me, this is a thing called a T-dongle S3. And it is it's from Liligo. I can't really say that I recommend the device. It's got an ESP32 S3 on a USB stick. That part's nice. It's got a little screen on it even. I actually have not actually gotten the keep meaning to get around to setting up the plumbing to access the screen from Forth, but have not done so. And one of the reasons is there's sort of two downsides to this device. One is that in the very small time that I've used it, if you look very close, I don't know if it's visible on the camera, but the head of the USB connector, after being inserted and removed, it's kind of a tight connector, and it's stuck and actually came undone. So I needed to super glue it. So that bodes poorly. Second problem with the device is that if it's plugged in for more than a very short span of time, it gets very warm. So it seems to be kind of a questionable design, and that's one of the reasons I haven't spent a lot of time working on it. It's not very fun to work with a device that gets hot to the touch, and frankly, it worries me a little in terms of how stable it is. But nonetheless, I'm going to use this one for the sample just because it's convenient to carry around and stick in a pocket and so on. So when you stick a device in into the serial port on a Windows machine, it will, let's see if I can point the thing the right way around, it will make a little chirp. And then let me make sure that this, so this site, if you, in Chrome, if you click on the, if you click on this little button up here, you'll see various things about the site. And if you now, let me go back into that web vocabulary, and if I do paraserial, this is going to, and actually, okay, so I'm gonna, this will offer, can folks see this dialog, or did that get treated by Zoom as a separate window? Can folks see a dialog that refers to USB serial debug unit?
Yes, we see a dialog.
Excellent, thank you. So, so this pops up a dialog and shows the list of serial devices connected, and so I can select this unit and then say connect. And so after that, now there's a relationship between this website and the serial device. And so in the future, it's assumed that this website is able to access that particular device when it's plugged in. If you click on this item now, there's this permission that's been granted. And so now I can enter serial mode, and you'll get a little bit of leftover of whatever was in the buffer from that device, and you'll see that I'm here in the inside of this this ESP32forth. So it doesn't look particularly different, but notice this is actually the serial device that I've connected, and I'm able to interact with it and do things on the device. Let's see, so what are some things that I can do? So it has an SPI file system on it, so I can do an ls there. I can cat out whatever I've got in these. So there's some things I've stored in there. For those who've seen some of my prior talks, I've got a visual editor that's implemented. Actually, well, I can, so there's also blocks.fb, which is the block store in there. And I can list out, well, there's nothing in that block. Let's see if there's anything in block one. So there's something in that block. So I can list out blocks, or I can open up this file in the visual editor. And because this is a proper sort of, the terminal that I've implemented here is a sort of quasi VT100 ANSI terminal, it supports a number of different control codes and so on. So this little editor will work, and you can slide around in it. There's one little bug I've got where it'll carry over to the last line there. I can do control characters. One thing I actually realized in this is that I had never added control keys to the web editor, which this prompted me to add that. I'm not going to save over that. And so it's got sort of the full range of ANSI codes. There's a word that I have on the device for use with ANSI terminals to set the foreground color using escape codes, and like escape is oops. Oh, because that's probably in internals and oops. Too many vocabulary. No, it's not in internals. It must be in what vocabulary is that in? I'm not going to go look for that now. Regardless, so you can sort of set the foreground color, and it will change. You could have a loop and do a bunch of different colors, print them out, and then go back to normal, and so you could do something like that. And in general, so now if I reboot the device, the behavior is a little different depending on the particular device and the platform, but I noticed that it happily rebooted, and then I saw sort of it reconnected automatically, which is awfully nice. Like, it's actually some of the serial terminals, like PuTTY, kind of annoyingly disconnects, whereas this will sort of happily disconnect. If I pull the device out, now nothing's happening there. If I reload, oh yeah, so that segues nicely into. So this is, in this case right now, I'm back in I'm back in µEforth Web. I got a shortcut that has that page that I mentioned previously, where if you go to this URL, it will print that prompt, and it offers to pair. And then if you say no, it's just going to sit there. And if I plug in a device, now I've got my device connected. Obviously, one challenge would be if you were going to use this with multiple devices. Let me show an example. So suppose I reset the permission, so it's now forgotten about all the devices, and I'm going to plug in a second random ESP32 device that I've got. And now I'm going to hit pair again, and now there's two options here, right? So I can pick between the two different ones, and I'll pick actually don't know which is which. All right, well, I'm going to pick that one. All right, and then, oh, that's the other device. So this is a different ESP32. I think this is a classic ESP32. And so because there's only one device that's paired, it's going to favor that one. If there were several of them, if I, for example, reloaded and I offered a pair, and now maybe I'll also pick the other one, and now I've got that device. So I'm back on the ESP32 S3. So anyways, that is it. This is a utility that is out there. If you ever find yourself on a device and you don't want to, don't have access to a serial terminal, if you are able to remember this URL, this will allow you to connect to your device. It's not ESP32 specific, other than that the implementation is the web, the µEforth implementation that's shared. But it should be generic to sort of any serial device that you connect to it. So one less thing I'll have to install in future. I used to find myself installing PuTTY on devices to be able to talk to them with serial terminal. Any questions about that?
As usual, extremely impressive. And it really sort of touches on the major thing that to go and make Cozy a real product is to go and interface through the web. And I've got some other conversations going on that, but man, probably just supporting Cozy to µEforth, and with all of this and changing the interface to be through browsers. Just need to get together the funding for it. So, but yeah, Cozy or Forth can become. This is one of the things is Forth by itself is always going to be. I mean, it is unmatched in having this open interface to hardware. But in terms of doing everyday practical things, you have to build a higher level language upon it, which it is also uniquely able to do. So if you're going to go and replace C as the foundation of 21st century computing with Forth, then you need to have that stack. And my God, your interfacing with the web is just, to me, spectacular. If you don't mind the comment or the compliment.
Appreciated. Yeah, I think putting things out on the web is a great way to make them accessible. My understanding from folks that actually worked on adding this API to Chrome, one of the main reasons they actually wanted to have support for this is actually thinking of Arduinos and that type of thing in the education market. You know, being able to have that be something that you could access, for example, from a Chromebook, is useful, because then you have that makes that something that you can bring to that environment. It makes it, easier to set up than trying to fuss with configuring devices and so on. So,
Hey, Brad.
yeah.
There are other JavaScript ports out there. Like, for instance, I posted one just above the µEforth,
Mm-hmm.
and to me, that one is targeted just to, learning Forth and beginners, and, does a snake game. But my question is, have you compared your JavaScript Forth to any other JavaScript Forth, and what do you have to say on that?
It's a good question. Like the one you pasted in the link, I've seen there's a number of folks that will do it, because it's the great thing about Forth is it is a simple language, and so it's sort of straightforward to implement, and so folks will do that, and that's great. I think I guess the virtues I can say for µEforth of the web is that it's essentially the same implementation as Esp32forth. So it's the same kernel that runs on it, that runs on the embedded version. There's a little bit of there's obviously, unfortunately, more than a little bit of JavaScript shenanigans to be able to offer an environment that looks enough like a native environment to be able to coax it to run on the web. But there's sort of that correlation between a thing that can run on the device versus a thing that runs on the web. So I would say maybe that's one difference. A lot of the JavaScript forths that I've seen tend towards toys. This one, at least, that you pointed to, looks like it does some set of things. I think one challenge always with the web is that the API surface of the web is relatively large, and is different to Forth in the sense that it tends to be, where Forth tends to towards synchronous operations, JavaScript tends to, particularly in the web, tends to be about asynchronous operations, and so bridging that gap is tricky. And so then what folks will do is they'll come up with they'll invent some abstraction around that. I've tried to sort of, with µEforth, offer terminal and a little bit of kind of straightforward things, and then mostly just assume that there'll be a thunk out to some JavaScript that gets embedded in line. So I think it's a I guess the other virtue I could point out with µEforth is as you saw with that sample, you can include a single file, and then you can use it, create a script tag that embeds it and use it that way. That said, I don't know that it's particularly well documented. It's a number of different deficiencies to it. I think it's a hard business being on the web for a forth, just because the web has inescapable complexity, and then forth sort of you can easily get sucked into that, and it's not forth's sort of at some point, are you doing JavaScript? Are you doing forth? Are you doing some hybrid between the two? So, but I do put some of these things up on the web just because it is so tempting in terms of how accessible you can make things. And certainly one follow on I have in mind for this is that now that I've got it actually talking to the serial port, a lot of these devices, the ESP32s, they can also be programmed over the serial port. And so sort of a thing in the back of my head that I'd like to be able to do is have a sort of a built binary for µEforth, and then be able to tell somebody you want to put eForth on your ESP32, plug it in, go to a website, click yes to a permission prompt, and then have it install without you having to even install the Arduino tools or something like that. So there's tempting things that you can do on the web to make things smooth and easy, but by the same token, it's complex. So
yeah, just one of the things that I really appreciated about µEforth, I posted another text. At the bottom of the web page is this list of scripts, which is, I guess, the modularity of this particular implementation of Forth. And you can see that it's very easy to understand. It's, and so that's the only thing that I was so impressed with µEforth is, oh my goodness, look at this modularity, look at this. And I've looked at the individual files, and it was a pleasure reading them. So
I'll check it out in more depth. I haven't seen this particular one, and it does, as you say, it looks a little bit more full featured than sometimes I've seen ones where they're kind of borderline on toys, and I'm just poking with it now as we've been chatting. I'm noticing that seems to have kind of the core of a real system there. And so some of the things that folks, some of my early JavaScript forths, it's very easy to sort of slide into something where you've kind of emulated facets of forth, but then you kind of don't have enough that you can sort of do some of the more sophisticated things like create does and so on. So it's interesting to see a more extensive implementation from someone else. I haven't seen quite as many. Right. I haven't seen this particular one, so we'll check it out. So it looks like this one doesn't have create does.
Yeah, it's targeted for beginners. I'm sure that would be an interesting thing to add. They on the page, they invite other forthers to extend the teaching experience, but I'm not sure that create does. It's like trial by fire if you're gonna throw a complete beginner into create does. Oh my goodness.
Certainly, and I do admire the fact that they've structured it as a tutorial. There's definitely the other thing the web is great at is sort of being able to have a thing that takes you step by step. Here's what you would do to understand this, and definitely worth thinking about. That could be something I could take µEforth and embed it in a tutorial. And
as a tutorial, I really appreciate the fact that every single forth in the page is actually sort of separate from each other.
Yeah, it's nice to have that kind of notebook style interactive environment, definitely.
All right, I'm done. Thank you. Thank you so much, Brad.
Back to you, Kevin, I guess, unless there's
All right then. Brad, if I wanted to develop something on an embedded system, is there a mechanism to, for want of a better word, to telnet into something that's got a operating system running on it, and uh, from a tethered forth standpoint, do a, I guess you'd simulate a serial link over the network.
Well, I mean, if you're looking for an environment, I mean, in some sense, that's actually kind of the goal of the thing I just presented is that if you've got a device and it's been programmed already with a forth, then you can connect it and now just in the web browser interact with it. I guess the missing bit in terms of making it really easy would be if the web page could program that ESP32 device or some other kind of device, that would be particularly cool, because then you could just tell somebody, buy this piece of hardware, stick it in the slot, go to this web page, and then it will sort of guide you. Right now, you would need to download the Arduino tools, install something on this whatever device, and then you could use the web page. So kind of missing one link in the chain.
There's a rumpus on somebody's line. It's not me. It must be Dave. I don't see anybody else's mics open, so I'm confused. All right.
There are folks out there, by the way, with our friend Peter Forth has pointed at me at there's an emulator. Somebody's got an entire sort of simulator of ESP32 that runs in the browser. It's very slow, even on a decent machine I've found, but it will let you take an Arduino sketch, compile it, install it onto sort of a virtual embedded device and interact with it. And it does, you can actually fire up ESP32forth in it and so on, but it's very, very roundabout, because you're basically you got your source file and compile your C code and install it into this virtual device, and then it runs terribly slow and so on. But it is a thing that's out there. So.
A while ago, there was some interest in making a IBM 1130 forth available on the web. I don't know if anybody ever got it bundled, duct taped together so that you could just hit the button and go and suck up your card deck and spit out your... Reminds me of many, many years ago where the IBM Federal Systems division had a guy that built a simulator for a new computer architecture they were working on, and there was a real simulator that they built, and he built his in forth in his copious spare time in the middle of all the other panic associated with this. And as it turns out, his worked so much better. I guess he was the prime speaker on Fourth Day at the dinner many years ago in one of the convention centers in one of the hotels. I wonder if there's a record of who spoke when and did what. We have some of the meeting notices available online, but so much of that is lost in the mists of time. All right, so Dave Jaffe and me. Who is that? With background noise.
That's me. That's me.
You have background noise, Dave?
Yeah, there's people outside, and so I think they're going to quiet down. So I hope so, at least. Okay, let's find the right screen.
Hecklers are welcome. You can unmute and speak if you care to. Zoom user, you still haven't changed your name to your name.
Okay. Are you seeing my...
I am seeing your copy of what looks like PowerPoint.
Okay, now it should be